Hello students, in function now we know what is domain, what is range and the graph. Now in this lecture we are continuing with the graph and based on the graph and domain range we have to solve the question. So different type of questions we are solving, right? Applying the concept of graph and now enjoying the topic with us, right? So let's get the starts the topic. Hi students. In this lecture, we are going to solve question of range. In question of range, we have already seen that if the question of domain and range is given, how to find that, right? Like in this, I'm giving you one equation as y is equals to x upon x square plus 1. We have to find range of this function, right? Maybe the question would be in the form of linear by quadratic, maybe only quadratic, maybe quadratic upon quadratic, maybe quadratic upon linear, right? Any form of equation is given, then we can apply this method. What is this method? See, cross multiply this x square plus 1, we are getting y into x square plus 1 is equals to x only. Now y into x square plus y is equal to x. Now rearrange the complete equation as yx square minus x plus y is equal to 0. In this you can see that coefficient of x square is y, right? Coefficient of x is minus 1 and the constant term for this case is y. And with the basic definition, we know that discriminant of this must be greater than or equal to 0. The discriminant is nothing but b square minus 4ac. So this discriminant in this case will be b square 1 minus 4ac, 1 minus y square. So now I have to solve for 1 minus 4 y square must be greater than equal to 0, or we can rewrite this as 2y the whole square minus 1 square. Since we are multiplying this with minus sign, so this inequality sign will change and this will go to less than equal to 0. And with the factorization, this is giving 2y plus 1 into 2y minus 1, right? This minus 1 less than equal to 0. In the number line, we can see the first one will be 0 at minus half and second will be 0 at half. Put any value greater than half, positive, negative, positive. And what we require less than equal to 0. So this is the portion that will be less than equal to 0. So our required answer for this case, right? This must be between minus half to plus half, or the value will be between minus half to plus half with a closed interval, because this is given equality sign. So range of this function in this case will be minus half to plus half, or we can say the value of y belongs to minus half to plus half. For the case, this is called, the y is called the range, right? Now, in the second example, if I'm taking as y is equals to twice of greatest integer x plus 4, where restricted x belongs to 0 to 3. X belongs to 0 to 3. We have to find range of this function now. Y is equal to twice of greatest integer x plus 4, right? X belongs to 0 to 3. Now, in this portion, we know that like this is a step function. So we have to solve this stepwise, like x lying between 0 to 1 is the first case. Second, x lying between 1 to 2. Third case, x lying between 2 to 3. And the fourth case, x is equal to 3. So one by one, we have to go first case, second case, third, and fourth. Right? When x is lying between 0 to 1, we know that the greatest integer will be 0. So this will be 2 into 0 plus 4. Right? In second case, we are getting y is equal to, when x lying between 1 to 2, we know that if x is lying between 1 to 2, the left integer is 1. So greatest integer in this case will be 1, right? Greatest integer is 1, so this will be 2 into 1 plus 4, right? Case third, when x lying between 2 to 3, greatest integer x will be 2 only, right? In this case, we are getting y is equal to 2 into 2 plus 4, and the last case, since x is 3 only, so 2 into 3 plus 4. So in all the cases, we can see what we are getting. We are getting, first case, we are getting y is equal to 4 only, right? Second case, it's 6, 8, and then 10. So discrete values are coming in this. So y belongs to the values either 4, 6, 8, or 10. See, in this case, I'm using this curly bracket. When we have to write only the discrete values like 4, 6, 8, 10. So for discrete values, we have to use the curly bracket. So y belongs to only 4 values are there, 4, 6, 8, and 10. We can also solve this with the help of graph. See, we have to draw the graph for x belongs to 0 to 3 only. So it is given. First, we are drawing the graph of y is equals to greatest integer of x for x belongs to 0 to 3. Y-axis, x-axis, let this is 0, 1, 2, 3, right? So 0 to 1, graph will be 0 only, right? 1 to 2, it will be 1 only. Then it is 2, and then only the value is 3. So when x is lying between 0 to 1, we are getting graph as 0, right? At 1 to 2, when the x value of x is going for 1 to 2, the value of y is 1 only. For 2 to 3, we are getting 2, and exactly for 3, we are getting 3. Now, so, but we have to find y is equals to twice of greatest integer x. So we have to multiply this greatest integer x by 2. So for the transformation in this case, what we can do, we have to multiply this y by 2. So the new graph will be same, but it will extended in y form, right? This was 0, right? So this will be 0 only. At 1, let this is 1. So 1, we have to get the value as, at 1, we are getting 1. Now this will be 2 only, right? So this value will be 2, right? At 2 to 3, this value was 2. Now multiplying with 2, so we are getting 4. At 3, this will be 6, right? Now we have to add 4 on this. So the graph will be added with 4. So the every point will be increased by 4 unit. So the 0 will be going to 4 now, right? This 2 unit will going to 6 now. 6 and this 4 unit will be 8 and 6 unit will go for 10. So this is 4, this is y is equal to 6, this is y is equal to 8 and 10. So in this case we are getting 4 values, 4, 6, 8 and 10. This is range of y, or you are getting the value in this form, right? Now we have already seen the graph of signum function, right? Y is equals to SGN X, but I'm giving you the graph for y is equal to signum of x square plus 1. So what would be the graph of this? We know that for any signum function SGN fx, we have to see 3 things. First, fx greater than 0, so graph will be of 1. Fx equal to 0, the graph will be of 0. If fx is less than 0, we have to draw the graph of -1. So when we have to draw the graph for y is equal to any signum function, so y will be split into 3 parts. Means only we have to check in this case the function like x square plus 1, what value this is given to. We know that x square is positive, plus 1 will be always positive for all x belongs to R. So this x square plus 1 is always positive. So signum of any positive number is always 1. So in this case, we can say y is equal to 1 is the singleton set, or the range in this case is 1 only. So the graph we can say, since we know that graph of x square plus 1 is something like this. So this is always positive, right? So draw the graph. Y is equal to 1 will be the graph of this. So in different form, we can draw the graph, right? So we have to take care of the function itself, right? One very important example again, going with the quadratic one, but in the different form I'm giving you, like x square plus x plus 1 upon x square minus x plus 1. We have to draw the graph of this, or we can say if we have to find the range. Drawing the graph is a little bit difficult now, but 100% when we'll know about the derivatives, know about the where this will give the minimum and maximum, then we will be able to draw the graph. But till that, we have to solve for range, right? So the basic fundamental, cross multiply this, right? Now transfer this y minus 1 x square minus of y plus 1 into x, right? Plus y transferring this one minus 1 is equal to 0, right? In this case, we can see a is equal to y minus 1, b is equal to minus of y plus 1, and c is y minus 1. Only we have to apply the concept d greater than equal to 0. The discriminant will be greater than equal to 0, right? So discriminant on this case, b square minus 4a is y minus 1, c is y minus 1 greater than equal to 0, right? So b square minus 4ac, right? We can solve this y plus 1 the whole square minus 4 y minus 1 the whole square by like expand this, and we can solve, or The best way while solving this is y plus 1 whole square minus twice of y minus 1 the whole square greater than equal to 0. Or we can rewrite as y plus 1 the whole square minus 2y minus 2 the whole square greater than equal to 0. Right? Some of the roots, right? 3y, right, minus 1. And if I'm writing y plus 1 minus of this, so minus y minus 1 minus 2 will be plus of 3 greater than equal to 0, right? So see, coefficient of y contain the minus sign, right? So we can do two things. Either we can take out this y, or we can just draw the wavy curve for this only, right? So if I'm taking minus sign from this, I'm getting minus of 3y minus 1 and y minus 3 greater than equal to 0, multiplying minus sign both sides, 3y minus 1 into y minus 3 less than equal to 0, right? So this is the number line, right? This will be 0 at 1 by 3 and this is 0 at 3, right? Put any value greater than 3, let 10. So this both will be positive. Then we know that alternatively this will change the sign. So positive to negative, then again positive. What we require less than equal to 0. So this is the portion and equality sign is there. So the range in this case, y belongs to 1 by 3 to 3 closed, right? Later on, we'll draw the graph of this and we can solve this by graph, right? So quadratic is very important for you. If we are able to solve the quadratic in like good manner, lot many question of range we can solve, right? One more question, just going for y is equals to sin square x plus cos to the power 4x. See this carefully. How we can use the graph to know the function and drawing the graph is very helpful to know the range of the function. See, this would be the example for you, right? Sin square x is nothing but 1 minus cos square x plus cos to the power 4x. Suppose in this case, I'm saying cos square x is t, right? If we are taking cos square x is t, t lies between 0 to 1, right? A square of any quantity will be always greater than equal to 0. And we know that cos theta is maximum cos theta will be 1, right? Cos 0 is 1. So maximum it can go up to 1. That's the reason this t or cos square x is bounded between 0 to 1, right? So if I have taken t, so this is y is equal to t square. This cos to the power 4x, I'm writing t square minus t plus 1, right? T square minus t plus 1. We have to draw the graph. This graph, right, what graph of quadratic. Or by transformation also we can do, right? So at x is equal to 0, or we can by whole square term t minus half the whole square plus 3 by 4, completing the square. So at 1 by 2, this will be 3 by 4. Right? At 0, this will be 1 and 3 by 4 containing this or going like this. This is the value 0 at x is equal to 0, we are getting 1. This is the point where I can say at half we are getting 3 by 4. And this is the point we can say this is the point, this is 1 comma 1. And this is going for negative and this is going for more than value 1. Now, see. Just I'm going with the different color. Let's right. See what we have to do, right? This is the graph and t is bounded between 0 to 1. Careful, everyone. Say this carefully, right? We have to see the graph for 0 to 1 only. right? Between 0 to 1, what is the minimum and what is the maximum value we are getting? That would be the answer for you, right? Look, between 0 to 1, we can see at 0 we are getting 1, at 1 we are getting 1, but in between what we are getting is 3 by 4. So minimum of this will be 3 by 4, maximum of this will be 1. So we are going from 3 by 4 to 1. So range of the function will be 3 by 4 to 1. This is one of the easiest way you can draw the graph, and with the help of the graph, we can easily, right, take out the values of range, right, with the help of graph. Now, y is equals to sine to the power 4x plus cos to the power 4x. This is one of the simplest formula we can say, and we have to find again range of the function. How to find range in this case? Again, if you want, you can go with the graphs. See, y is equals to, I can say this is sine square x plus cos square x the whole square minus 2 into sine square x into cos square x. This is 1 minus, right, multiplying and divided by 2. This is 2 sine x cos x the whole square, right? Or this is the formula of sine 2x, 1 minus 1 by 2 sine 2x the whole square, right? This is the formula for sine 2x, the angle, right? The split into 2 sine x into cos x. So sine 2x, right? Sine 2x with square. This value again lies between 0 to 1, right? Let's suppose again I'm assuming this 1 by 2 and sine as t, so this will be t square, right? This t is lying between minus 1 to 1, and I'm taking sine 2x as t, right? So we have to draw the graph of y is equal to 1 minus t square by 2, and then we have to see what is coming in between, right? Y-axis, x-axis, c. Y is equal to 1 minus, right? So this is y-axis. Now this will be t-axis because we have to draw the graph for t. At 0, this will be 1, right? And coefficient of t square is negative, so this is going downward, right? At root 2 and minus root 2, this will be 0, right? But again, to see this, we'll change the color. See, this will be 0 at these 2 points. If we'll equate this 0, this will be root 2 comma 0 and minus root 2 comma 0, right? But this is sine x, right? We have to do this for minus 1. The sine x lies between minus 1 to plus 1, right? If sine square x is there, so this lies between 0 and 1. Both the case, we are getting the same thing. This was a point 0 comma 1. At x is equal to 0, we were getting this. And this at 1, right, this value will be half. When t is equal to 1, you are getting half, right? So only this, only between this you have to see. So minimum value of this is half, maximum of this is 1. So again, you are getting y belongs to half to 1, right? So minimum of this is 1 by 2, maximum is 1. So this is the range of the function, right? So next class we'll start the previous year question on this. So, right, use more and more graph to solve the question, right? Thank you.